Hello everyone, this is Mr. Osama. Today inshallah we are going to talk about the chapter 8 lesson 7 algebra readiness for grade 7, which is called the linear inequality. First of all, we need to have the definition of the equation before we move to the inequality. We had before the definition of the equation that two algebraic expressions are equal, so the equation has an equal sign. Today inshallah we are going to talk about the inequality. Inequality is a little bit different than the equation. So the definition of the inequality is two algebraic expression not equals. We have to confirm this is not equals. So in the equation, if we replaced the equal sign by greater than or less than or greater than or equal or less than or equal, instead of the equal sign, the equation will be inequality. So we need to understand this by taking a small note. So if I said, for example, x or y, I'm gonna say y equal 3x plus 2. This is an equation. Why? Because this contains an equal sign, which is here. Contains an equal sign. So this is equal sign will make the expression y equal 3x plus 2 is an equation. And we had this in the previous sections. But today inshallah we are going to talk about the inequality. As we said, the definition of the inequality is two algebraic expressions not equal. So I'm gonna say, if I'm gonna replace this is equal sign by any inequality sign, I'm gonna say, for example, y is greater than 3x plus 2. This will be inequality, not equation. Inequality. So this will be inequality, not an equation. So we got the difference between the definition of both of them. We need to move to the next part, which is the solution of each. The solution of the equation, as we had before, is just one value to find out the value of x. This is what we call the equation. If the equation has two variables like x and y, the solution will be an ordered pair. So we need to focus on one thing. If the equation in one variable, the solution will be one value for x. If the equation in two variables, the solution of the equation will be in an ordered pair. So this will be value for x and value for y. Today is a little bit different, which is inequality. The solution of the inequality is gonna be different than the solution of the equation. The solution of the inequality is infinity solutions, many solutions. So we have to go through some procedures to let you understand how to find out the solution of the inequality. And now we are going to start explaining how to graph the inequality. So I'm gonna move up a little bit. Right now we need to know how to graph the inequality and identify the solution of the inequality. We are focusing on this session on the linear inequality. As we had before, the linear means the exponent of x and y will be 1. The exponent of x and y will be 1. For example, if I said y greater than x plus 2, this is an inequality. We need to graph this is inequality. So I'm going to explain the procedures for graphing the inequality. How to do this? First procedure is to consider the inequality as an linear equation. So I'm going to say the first procedure would be let y equals x plus 2. This is the first procedure. So this is the first procedure. Why we consider y equal x plus 2? To graph what we call the bounded line. What is the bounded line for the inequality? The bounded line is the line that drawn or graphed on the xy coordinates to identify exactly where the area of the inequality will be. What we call the target area. For the inequality. And this area will contains all the solutions of the inequality. And you have to understand this solution will be an ordered pairs. pairs. The first procedure is to let y equal x plus 2. The second procedure is, I'm gonna move up a little bit. I'm gonna consider y equal x plus 2, so I have to push step number 2, graph y equal x plus 2 at a linear equation. So I'm gonna make a table of values for that. I'm gonna use x and y. I'm gonna do some points. It's gonna be like 2 points or 3, it's up to you. So I'm gonna take with 0 and 1, for example, 0 and 1 for x. The corresponding values for y will be, when you replace x by 0, the result will be 2. When you replace x by 1, the result will be 3. So I got two ordered pairs, 0 and 2, 1 and 3. I'm gonna graph the linear inequality now. So this will be the second step. We need to move to the third step. The third step is to highlight or graph the xy coordinates. So I'm gonna graph xy coordinates to draw the line, what we call the bounded line. What we call it, the bounded line. So here I'm gonna highlight the intersection points with 0 and 2, 1 and 0 and 2 is gonna be here, 0 and 2, and 1 and 3. This is 1 and this will be 3 here. So I'm gonna highlight here the point, which is 1 and 3 here. So I have 2 points now. The 2 points now, I need to line up the 2 points. Before we're lining up the 2 points, I need to give you some axioms. Axiom number 1. Axiom number 1. Before we line up the 2 points. Axiom number 1 states that if the inequality sign contains equal sign like this, or less than or greater than including equal sign, that means the bounded line will be a solid line, a solid line. But if it contains, if the inequality sign does not contain equal sign, the inequality sign like this, I'm gonna move up a little bit. If for axiom number 2, if the inequality sign does not contain equal sign like this, the line will be dashed. The line, the bounded line will be dashed or scattered. Dashed line. But the previous one should be solid, or solid line, or straight line without any. So this will be solid line. This will be, in that case, will be solid line. Solid line, that means there is not dashed, and the other one will be dashed line. So we have to focus on this one. So in our case, in this example here, the y, the inequality, if we get back to the inequality, which is x plus 2, y greater than x plus 2, that means there is no equal sign, so the line will be a dashed line or scattered line. So I'm gonna pick up any different color here, so it's gonna be black. Okay, so this will be a black line here. So I need to do it scattered line, not solid. So I'm gonna use the eraser to move little bit points like this. So this will be scattered line. Scattered line means it's dashed line, so it's not straight 100%. What does it mean? It means that the points on the line itself is not a solution for the inequality. So I'm gonna move up a little bit. So here we need to have a remark. We need to have a remark here. Remark. State that if the line is dashed, it means that all the points on it is not a solution, is not a solution of the inequality, is not a solution of the inequality. So right now we highlight and we write down all the information about the line, the bounded line. We need to go to the third procedure, so I'm going to move up a little bit. The third procedure, number 3, we need to identify the target area which it contains all the solution of the inequality. So I have to use what you call the test point. The test point. What is the test point means? A test point is a point that chosen from the xy coordinates not belonging to the bounded line, and we have to make sure that point satisfy or not satisfying the inequality. How can we do that? First of all, I'm gonna pick up the point 0 and 0 because 0 and 0 is gonna be easy point. So 0 and 0 will be a test point, will be a test point. So I'm gonna replace in the inequality x by 0 and y by 0, and if the statement is true, that means the area which including 0 and 0 is a target area, or it's the solution area, or it will be the shaded area, or it will be the solution area. All this have the same meaning. So I'm gonna get back to the inequality, which is, I'm gonna move up a little bit up. The inequality states that y is greater than x plus 2. My test point is 0 and 0. I'm gonna replace, this is x and this is y. I'm gonna replace 0 instead of y. Inequality sign, I have to put a question mark to make sure if this one is correct or not. So I'm gonna replace x by 0 plus 2. Drop down 0 greater than question mark. 0 plus 2 is gonna be 2. I have to ask myself one question: does 0 greater than 2? And this is false. This is not correct. This is not correct. What does it mean? It means that 0 is not greater than 2. It tells us that the area which including 0 and 0 on the graph is not a solution. So I have to get back to the graph of the inequality, which is here. So this is 0 and 0. My target area, this is the point 0 and 0, and this is area which including this is point 0 and 0 is not a solution. So the solution will be the area on the top of. So I'm gonna highlight by green color. So this will be the area which is green area. This will be the solution of the inequality. What does it mean? It means that all the points which is an ordered pairs include on that area, on the green area, it will be a solution for the inequality, not including the points on the line, not including the point on the line itself. So you have to understand, you guys, here that the answer will be the green area, all the green area which including all the ordered pairs except the points on the line itself is not a solution for the inequality, but all the points on the green area, it's a solution of the inequality. And this will cover the graphical representation of the inequality and how to solve the inequality graphically. Next, we need to have another example to for the we had for the dashed line. We need to have another example for the solid line. So I'm gonna write down another example. Example number 2. I'm gonna change the color to make it red. So example number 2. Example number 2. Solve or graph. It's better. Solve and graph, the same meaning. Solve and graph the inequality, or we can make it graph. It's better. We can make it graph. It's better. Of the inequality. Graph the inequality. Graph y less than or equal x minus 1. How to graph this is inequality? We have to go through the procedures we've been through. So I have to start with finding out the bounded line. So I'm gonna consider, so I'm gonna move up a little bit here. Let y equal x minus 1, x minus not plus, x minus 1. So I have to graph this line by making the table of values of this line, which is, this is x and this is y. I'm gonna use 0 and 1 for example. It's gonna be easy for me. When you replace x by 0, it's gonna be -1. When you replace x by 1, it's gonna be 0. The next procedure is to make the xy coordinates. Make xy coordinates. I'm gonna highlight xy coordinates here. This will be xy coordinates. This is xy coordinates. I have to graph the line which is y equal x minus 1. First of all, if the inequality contains an equal sign here, as we had, that means the line will be solid line. So here I have to make sure that the line will be solid. So I have to highlight the 2 points which are 0 and -1. So 0, I'm gonna use a different color. 0, I'm going to use 0 and -1 will be down here, will be down, 0 and -1, and the other one, the other point is 1 and 0. I think it was 1 and 0, 1 and 0, yes. So I'm going to write down here 1 and 0. I'm going to graph 1 and 0. This is 1 and 0 here. This is 1 and 0. So I have 2 points, 0 and 1 and 1 and 0 and -1 and 1 and 0. I'm gonna highlight, I'm gonna line up the 2 points, and the line will be, by the way, it's solid line, not dashed line, because we have an equal sign and this is inequality. So I'm gonna use a different color here. I'm gonna use a red color. Smart. I'm gonna use this, will be my line exactly. This is a line which we're looking for. And we need to highlight the area which is going to be the target area by using the test point. The number 3, which is the test point, I'm going to highlight the test point. The test point will be, test point be 0 and 0. So 0 and 0. I'm going to replace 0 and 0 in the inequality and check if the statement is true or not. So I'm going to get the inequality y less than or equal x minus 1. So I'm going to replace x and y by 0 and 0, 0 minus 1, so 0 less than or equal -1. First of all, you have to check, does this inequality true statement or not? True statement or not? This is 0 is less than -1, and this is not true. This is not true because 0 is greater than -1. That means the target area not including 0 and 0. So it will be, I'm gonna change the color to make it perfect. I'm gonna use a blue color. So the target area of the solution is not including 0 and 0. So it's gonna be the other part of the line. So it will be here. It will be here. So I'm gonna highlight a little bit. I'm gonna use the different color. It will be here. This is my target area. The blue area will be my target area. Why? Because it's not including 0 and 0 and including the points on the line itself. So right now I'm gonna minimize it a little bit to find out, to write down here. So here in this is part of session, we highlight the target area, which is this solution. So this will be the solution of the equation. This will be the solution of the inequality, the target area for the inequality. So you have to understand, you guys, here that we have to go through some procedures. The first procedure is to let the line and write down the bounded line. So I'm gonna write down, this is, it's called the bounded line. Bounded line. The bounded line. The bounded line is very important, and you have to identify the type of the bounded line, if it's dashed or solid. It related to the inequality sign. If it includes equal sign, that means it's solid. If it's not including the equal sign, that means it's dashed or scattered line. The second procedure is to find out the to graph it, then you have to highlight the target point, which is called the test point. The test point will be 0 and 0, so a point is not including to the line. Then you make the substitution of break into the given inequality, then test the inequality if it's true statement or not. Once if it's true, that means this point is including in the area. If it's not a true statement, that means the point it's out of the target area, which is the solution of the inequality. Here in this case you have to understand one thing, that all the points on the line is included in the solution. So all the points on the line and the blue area will be a solution for the given inequality. Thank you guys, we're done with this video for today. Thank you for watching the video, and I hope you got everything clear. Thank you again and have a good time. Goodbye and good luck.